All right, so I've shared my screen. Are you able to see it?
Yes.
Okay. Okay, so basically we were on 4.5 last time. And in this class, we are going to discuss the last example, the one which I started last time, but I did not explain because like we did not have enough time. So I'll write down the question quickly and we'll start off, okay? So it's to have a mean mass of. Do you remember what we studied in last class? Were you able to understand all that?
Yes.
Okay, that's good. Even if you didn't, that's completely okay because like this example would help you recall everything. Like I do understand at times, students, they don't get enough time to revise their old, class content. So it's okay. This example would help you recall everything. Okay, so we are done with the question. Deviation of 3.2 grams. Okay. Now the question says, forget what the section was, forget, that it's an example. Just think of it as a new class, right? So you have a question. The question says, a random sample of 50 bags of sugar is taken from a production line and found to have a mean mass of 502 grams and standard deviation of 3.2 grams. Okay, all right. Now we have our data that the mean mass of the sample, okay? So be very clear about these things. Sample mean, that is, how do we write sample mean, Ranjani? It's x
Mu.
bar, x bar. Okay, mu is for population, right? That's
Yes.
okay. So it is 502 grams, and then we have standard
The standard
deviation. Yes, and how do we write this for the sample? We just,
sigma. Sigma square.
yeah, sigma is for the population, okay?
Population.
It's just a small s. So this is the sample. For sample, we have s, okay?
Yeah.
Right? Are you clear with the notation now?
Yes.
Okay, I'll explain the notation after this example. Just know that the sample mean is 502 and the standard deviation of the sample is 3.2. Okay. All right. So we have our data and we are good to go with the first part. All right. Now, in the first part, they are saying calculate an unbiased estimate of, again, standard deviation right. Okay, this much question is enough. All right, now we have to solve this question. But the very first question is that we have been given with the standard deviation, then why are they again asking us to find the standard deviation? Okay, so be very clear, Anjani. In statistics, for every parameter, after the section, you will discover another parameter. Like so far, we know mean, we know variance, we know standard deviation, but after this, you'll get to see another parameter as well, right? For every parameter in statistics, we have divided things into sample and population. Okay, sample is what we take as a reference of the population because like we cannot deal with all of the population. So just to have a good idea of how the population would be, we just pick up a random sample, right? So be very clear. X bar is sample mean, but mu is population mean, right? So there are differences, which I will tell you after this question. That is okay if you don't know them so far. Okay. Now the question here is, you have to find an unbiased estimate of the standard deviation, but here you already have standard deviation. So the difference is that this standard deviation is basically the standard deviation of the sample, because here in the question you have been discussing, you have been talking about the sample only. And here they want you to find the standard deviation of, although they have not mentioned it here, but you should know that this is for the population, right? Because like the one which is given is for the sample, it's mentioned. So this one would be for population. Okay, we know that. All right, so we know that. Let's write down the formula. Okay, in statistics, the best part about statistics is, even if you, although being a mathematician, I would never say that even if you don't understand anything, but yes, to get marks, you can even get, like in maths, you can always get full marks, but in statistics, you should just know the formulas and then try making the logic, and you're good to go. Okay. All right, now let's just do it quickly. Okay. All right, now again, we have been asked to find an unbiased estimate of standard deviation. After this much discussion, we know that this standard deviation is of the population. Okay, so without wasting any time, let's just write down the formula, and I'll share the formula list with you just so you are clear with every formula. Okay, all right, so x minus x bar. Okay, so this is the formula for variance of the population. Okay, this is basically the variance of population. Okay, so standard deviation is under root variance, that would be sigma. That is clear. That is clear. But the question is that how are we going to calculate x bar? How are we going to get our x's? Like in the question, you can see as well that although we have x bar, we have 502, this is given, this is the mean mass, this is the sample mean, which is x bar. Okay, we have this, but we do not have the individual x's, right? Can you see any list of data? Can you see the list of these, 50 bags? Do you see any 50 numbers being written in the question?
No.
No, right? So here you have to be clear now. Okay, in mathematics, it's not necessary that things can be done in any way. You need to play with formulas. Okay, so this is the formula for variance of population. Now let's just write down the formula for variance of the sample. The only difference is 1 by n summation x minus x bar whole square, right? And here we know that this is 3.2. This has been given. Sample standard deviation 3.2. So standard deviation is 3.2. So the variance would be,
3.2 square.
very good, equals 1 by, what would be n?
N is 50.
Excellent. Okay. And let's write it down as x, because no, x is not a good variable. Let's write it down as capital A. Okay, because like we already have x for something, so let's use it as capital A. Why I'm using it as capital A? Because I just don't know what the value of this expression would be. I do not have these individual x's. Okay, so this is going to be 3.2 square into 50 equals A. Okay, so far I have this part. All right, now let's try using this formula again. Like we have the value of this part, right? A is the value of this part. So sigma square is going to be 1 over n minus 1 would be, Ranjani?
49.
Very good. Into what is going to come?
X minus x bar. So
Yeah, so we have just used another formula for finding the value of,
will it be 512?
we have multiplied 3.2 square into
50.
50. Perfect. Excellent. Very
Yes.
well done. Okay. All right. So here I am going to, I'll write the value of A as it is. Okay. Just so I can give reference to this 3 point square into 50, because I've already written it that way, into 50. Okay. This is what we are getting. And finally, I can write it as, because I need standard deviation. Ranjani, be very clear. This is variance, okay? Students, lose marks this way by just, making such mistakes. So yes, 3.2 square into 50 divided by 49, that is going to be 3.23. All right, so finally we got our population standard deviation. Calculate an unbiased estimate of standard deviation, which basically was for the population, because in the question we have been told for the sample. Here, this was the formula which we were supposed to use, but since we did not have any x, so we could not use it directly. Since we had this 3.2, so although at times they give you extra information just to confuse you, but this time around this information was needed, right? Using this 3.2, using this 3.2 and this formula, we were able to get this value, right? And we got this value as Ranjini, what is the value of this part?
512.
Very good, excellent. Okay, so we got it here. And finally, after just taking under root, we got the population standard deviation as 3.23. Okay, so I hope you're clear with this part.
Yes.
Okay, and okay, so you're clear with this part. I'll quickly rub it and I'll give you a quick, because we need to do this other parts as well. But before going to other parts, I'll make a quick table. Just note it down because this table is very important for you, especially when we're studying statistics, okay? Because like if you are not able to understand the variables, the terms, the notations, then you would not be able to understand things well. Okay. So far, it's a very small
I'm
table.
kind of getting confused between which formula to use
Okay,
because they
that
all
is
are called
completely
standard deviation
exactly.
and
That is completely okay. That is completely okay. Okay, so let's make a big table where I can write down the formulas as well. Don't worry, you will understand. Okay, all right. So far, just think that you know four formulas. Okay, we have only studied four formulas. Rest of the formulas which we have already studied, I would share them in the next section. Okay, and everything is linked, so don't worry. Okay, so we are going to talk about mean here, and we are going to talk about variance here. Okay, then the other thing is sample and population. Okay, so are you clear with the table heading so far?
yes.
All right, mean. So the sample mean is basically x bar and the population mean is mu, right? This is the
Okay.
difference. Let me draw mu in a better way. This is mu. Okay. Now, the sample variance is S square, okay? It's S square. And the population variance is sigma square. Just know how to denote sample mean, population mean, sample variance, and population variance. Okay, are you comfortable with this now?
Yes.
You can just learn it by this trick that the um, population parameters are basically written in a different way, right? Like mu is not what it's not an alphabet and sigma is not an alphabet, right? However, x and s are. So you can just learn things this way, that if you're coming across mu, you should know that okay, this is not an alphabet, so it would be related to the population. And so far you know that mu is mean, right? So like you would know okay, it's mean, and it is not an English alphabet. It is like either it's Latin or it's Greek, I don't know, but it's a different alphabet. It's a different character. It's not an English. So just know that this would be for population, and same goes for sigma. Okay, so you can use this as a trick. Okay, all right. So we are clear with how to denote sample mean, population mean, sample variance, population variance. Now the next thing is the formulas. Okay. Summation x by n. This is clear. We know whenever we have to find the mean, this is how we find the mean, right? And for the population mean, the formula is same. Okay.
Okay.
For this part, we have 1 by n x minus x bar square, and this is 1 by n minus 1 summation x minus x bar square. So the only difference in both these formulas is n minus 1 and n, right? So yeah, these are all the formulas. Okay, just note them down and you will get comfortable with them, don't worry. Just use any trick, any tip to just learn these formulas. For mean, the formulas are same. For variance, there's only difference in n and n minus 1.
What about the other formula where you said
Mhm.
E of X equals
Yes,
mu?
yes, yes.
That
Don't worry,
one.
don't worry about those formulas. We will discuss all the other formulas at the end. Okay. So far,
Okay.
just know these four formulas. Don't think about too many formulas. Okay, just know these formulas, and we will discuss those formulas in today's class. But at the end, because we will end this chapter, and I already planned to discuss the summary of the chapter. So we will discuss those as well. Okay, and I will share every formula with you. So don't worry. Okay,
Okay.
are you clear with these four?
Yes.
So I should rub them, right?
Yes.
Okay. All right. So far you just know the difference in population, sample, and that's it. Mean and variance. Okay. Let's talk about the second part now. Okay. Now the B part says, okay, calculate 99% confidence interval for mean of all bags of sugar produced. I'll just write it down this way. All bags produced. Okay. All right. Now this is the second part. Okay. Again, if you were not able to understand this part in the previous class, you will get a better idea of this. Okay. Now
Okay.
here they are saying you need to calculate 99% of confidence interval for mean of all bags produced. Okay. Now this all right here is very important. This all is telling you that they are talking about the population, right? All means
Yes.
that's the population, right? Okay, perfect. So even if you were not able to understand the contents of last class 100%, and like you were able to understand 50%, so I told you in the last class that the confidence interval is self-explanatory. It is an interval. Good. Perfect. For the mean of all bags, okay, so we need to find the interval for mean of all population mean. This different alphabet is basically for the population, right? Okay, so this is going to be an interval. This is perfect. Okay. So we need to know the function here. We need to know the function here. Okay. I am directly going to write down the formulas because you need to know the formulas directly. No derivation, nothing. So the formula is x bar minus sigma z by
Over root n.
excellent. And yes, and here I will get plus.
X plus
Mhm.
sigma z over root n.
Very well done. Perfect. Okay, so here is the fifth formula, right? Is the fifth formula just noted down as the formula for confidence interval of population mean. But Ranjani, you are in A levels, right? So you know that questions are not that straightforward, right? Like, I mean, they would not be that complicated, but like here they have mentioned it this way for mean of all bags. So this all is population, okay? This all is population, right? Okay. Now, once you have a formula, you can take out things from the question directly, right? All right. Now, okay. Now let's talk about X bar. X bar, what is X bar, Anjali? Like, what is X bar? Not the value, but what is X bar?
X bar is the sample mean.
Excellent. Very well done. Okay, so here we have sample, here we have mean, and it is 502, right?
2. Yeah,
Very well done.
502.
So let's just plug in the values. 502 minus, what is sigma? Like, what is sigma? Is it the population standard deviation, population variance, sample variance, or what?
It will be root of n. Oh, S is sample variance.
S square.
Sample standard
S,
deviation.
yeah. S is sample standard deviation. Very good. So sigma is for the
Root of.
no. Listen to me. Like S is for the sample, right? It is the standard deviation of the sample. So sigma is the standard deviation of the population. This is
Sample.
what I'm asking.
Okay.
Are you clear with this part?
Yes.
Like this is what I just explained by the table I made before this part. Are you clear with this? Tell me honestly.
Yes.
Okay, perfect. And what is the value of sigma? Sigma is standard deviation of population, which we calculated in the first part, right? So it was 3.23, okay? Like sigma was calculated in part A, it is 3.23. Okay, so it is 3.23 divided by under root n. What is n? 50?
Yeah.
And now the question is to find z. Sorry. Now you need to find z. Okay, so how are you going to do that? Tell me, please.
By approximating it to normal distribution.
Very well done. Okay.
So mu will be 502, or will it be 502 by 50?
Just give me a second. All right, so this was sigma was 3.23. This is 3.23 divided by under root n. Okay, I'll rub this part. All right. Just give me a minute, please. I'm sorry. Okay. So it is 3.23. Okay, and now we have z. You need to find z, right? So for finding z, we know that we will be using probability. Probability of z less than z would be, what would be the probability? Let's take things stepwise. Like we have discussed this part in last class. Since the confidence interval is 99%, okay, so I'll tell you again. I'll tell you again how to, okay. So you know, once you have your probability, you would be able to find z, right? But here the discussion is that
Yes.
how to find the probability. Okay, so I'm telling you again, we have already discussed this in the
So it
last
is
class.
99 by 100
Yes, and
times 50 by 2.
okay, 99 by 100 It is 99 by 100. Okay. So 99 by 100 is the probability of the shaded part, right? Plus we have 1% unshaded part.
Yes, 1/2.
Yeah, but first you have to convert 1%, right? Like 1% would be 0.01
0.01.
by 2. Excellent. Very well done. Okay, so this would basically be 0.995. This is the probab. So you are good with this part. Okay, excellent. So this would give you Z equals 2.576. Okay,
Yes.
perfect. So you have to multiply it with this part 2.576 less than equal to mu. Less than equal to everything would be same, but you will get a minus sign 3.23 into 2.576 divided by under root 50. So obviously here again we have 50. Okay, so this is going to give you 5.8 508 less than equal to mu less than equal to 503 point. Okay, so are you clear with this part? This is 2, sorry. Okay.
Yes, ma'am.
Now the only thing which you need to note down is this formula. You know how what x bar is, you know what sigma is, you know how to find z by probability, and you have n. Okay, so you can do it easily. That's very good. Excellent. Okay. Now I am going to get rid of like this part, and we'll do the final part, and then we'll go to the last section. Okay. So, like if you were not able to understand things in the last class, now if you are able to understand today's class, just know that you have understood everything. This is why I'm spending good time on this, because I already had this feeling that you were not able to understand things in last class, because like it happens. That's completely okay, because like we have been studying pure maths. So, when subject changes, obviously it's not that easy for the student to change his or her domain as well, right? That's completely okay. All right, now I am going to just write down the third part, the C part. Okay, so C part is, all right, let me just take out C part now. I don't know why it starts happening with my pen. Okay. All right, now this C part has more to do with probability, okay? Okay, so it says 3 different random samples of 50 bags of sugar are taken and 99% confidence interval is calculated for each. Find the probability that none of these intervals contains population mean. Okay, now let's just understand the question, right? So 3 different random samples of 50 bags. Okay, just think of this part as, you must be familiar with those questions that 3 balls are taken out of a bag. What is the probability that they would be red? Are you familiar with those questions?
Yes.
Okay, so think of this question that way, right? So three different random samples of 50 bags of sugar are taken, and 99% confidence interval is calculated for each. Okay, so this 99% of confidence interval implies that the probability that confidence interval does not contain mean would be, you can tell that, like if 99% is the probability.
1%.
Excellent, excellent. Okay, so we can write it as 1 minus 0.99, that is 0.01. Very well done. Okay, so far we are just dealing with the question. We have not discussed how to solve it because we have not actually read the question part. Now the question says, find the probability that none of these intervals contains population mean. All right. So basically, you have taken out three different random samples, right? So you will have 1, 2, 3. So you will be multiplying the probability that confidence interval does not contain mean 3 times, right? Because like they're saying none of these intervals, right? So you picked up three different samples, so you will be multiplying it 3 times. So this would be 0.01 into 0.01 into 0.01, that is 0.01 cube, and that would be 0.000001. So did you understand this question?
Yes, ma'am.
Are you sure you understood this part as well?
Yeah, because you're three different samples, so
Very
you
good.
have to multiply it too.
Yeah, and you have to
Okay.
multiply the probability that this does not contain because of this word none. Okay.
Yes.
Okay, so I should rub this, right? You're clear with this part.
Yes.
Okay, perfect. So we are finally in the last section. We are done with all the other sections. All right. All right. So the last section is 4.6. Confidence interval for a population proportion. Okay. All right. So I would like to give you a quick recap. In the last section, we have discussed how to find the confidence interval of Ranjani. What confidence interval for population mean? Okay. So you
Yes.
must be noticing that in the last section we were writing
Question.
mu. We were writing mu
Yeah.
in the center, right? But there's only a bit of difference. First, you have to understand what population proportion is, and then you only need to understand the formula. That's it. Okay, perfect. So I will just quickly write down. Okay. So the first point is that the population proportion is, it's quite self-explanatory, is fraction of the population that have a particular feature. For example, if your population is the residents of a city, right? And you are emphasizing on that out of 500 people of the population, how many own a car, right? So that feature is basically car. That feature is basically that how many people in the city or in the population have a car, right? So this is how, or maybe if you are in a hospital and you are seeing that how many of them are there for, let's say, any fever, like how many of the patients in the hospital are there to get their fever cured and stuff like that. Okay, so feature would vary from question to question, obviously. And the second important thing is that you would describe having this feature, right? Having car, having fever, having this feature as success. So, in statistics, we talk about success and failure both. Okay, so we are done with this part. I'll explain everything once we have
Can you
everything.
repeat it? This
Yeah,
part?
don't worry. I will repeat it. I will repeat it. Okay. So basically, here we are talking about population proportion. Population proportion is a fraction of population that have a particular feature. Okay, let's say you have a population where you have 1,000 people. Out of those 1,000 people, you are interested in knowing how many of those own a car, right? So that very thing, that very interest of yours, where you need to determine that how many of them own a car is the feature. You would describe having this feature as success. Like in S1, when you used to find the probability, that what would be the probability that you are tossing a coin and you get head. There we talk about success and failure, right? So this is how you can understand this, that if someone has a car, that probability would basically be the probability of success, and then you have to subtract it by 1, so that would give you the probability of failure, right?
Yes.
If you're not clear with this, that's completely okay. You will get a better understanding soon. Okay, now we have to talk about proportion of success. Okay, that basically is, again, formulas. So nothing to worry about. PS, that is basically x by n. This x is basically number of successes, okay? And n is the total number. Okay, so I'll give you a quick example, okay? Let me just take out the example. Okay, so let's say that the question is an experiment. I'm not writing it down, okay? I'm just explaining you on call. An experiment is performed 100 times. The number of successful outcomes is 46. Okay. So x would be 46. X is the number of successes and n would be 100. Okay. I'm just trying to give you a quick idea of what x is, right? So this is new for you. PS is new for you. Don't worry. PS is basically proportion of success, right? What is proportion? Proportion is a fraction. So just think of it as probability, because like this is what probability is, right? Whenever you have probability, you just write down, uh, in the numerator you have number of desired outcomes, and in the denominator you have the total outcomes, right? So this proportion is basically probability. Okay, so think of it as probability, and just know that proportion of success is written like this, and it's basically a fraction where you have x by n. Okay, just know this. Okay, all right.
Okay.
Now you'll get to know everything, don't worry. Okay, now x is binomially distributed. Okay, so e to the x would be np, right? This is what you have studied in statistics 1, as well as in one of the previous classes as well. Okay, we have discussed this, that whenever we
Yes.
have okay, perfect, variance of x, and what is this? N p,
Q.
yeah, so q is 1 minus p, right?
1 minus P.
Excellent. So okay, so let me write down everything, then I'll explain you everything. Just don't worry, everything is very would be easily understood by you, don't worry. This basically is going to be okay. Okay. All right. Now, here we are talking about the confidence interval for a population proportion, right? So, think of population proportion as P. This is P, right? All right. Think of it as P. Okay. And when we were talking about the confidence interval for mu, for the population mean, we had mu greater than equal to less than equal to an expression, right? So from the previous part, something which you can determine already is that when you had to find the confidence interval for population mean, you had mu here and you had an interval, right? So I am telling you that the population proportion is written as P. So by now, the only thing which you can determine is that, okay, you will have P here, right? Is this part clear?
Yes.
Initially, we were talking about the confidence interval for a population mean. So this is population mean and this is what you had. Now we have population proportion. It's written as P. So this is what you would have. Now we have to think of this in this part. Okay, perfect. So, okay. Now population proportion, because this is new, you need to understand this, is fraction of population that have a particular feature. Okay, you would describe having this feature as success, that if someone has, if probability of owning a car is zero point 0.6, then probability of success is 6, right? Okay,
Yes.
okay. Now we are done with the definitions and stuff like that. Now let's talk about the statistical part. Proportion of success proportion of success is basically the sample proportion, right? This is the sample proportion. So when I was talking to you in section 4.5, I told you that in the next section we are going to discover a new parameter, and there as well we will have a difference of sample and population. Do you remember that, my wordings?
Yes.
So here you have your new parameter, that is proportion. Just like mean, just like mu, just like standard deviation, this proportion is also a parameter. Okay, so don't take things like, don't think about it a lot. Think of proportion as a parameter like mu, like mean, like standard deviation. Okay, so proportion is a parameter, which means that it would have, sorry. Okay.
Nothing, ma'am.
Okay, so it would have population version and sample version both. Okay, in statistics, notations are very important. So for the population proportion, we write down P, and for the sample proportion, we write down P of S. Okay, all right, all right. So just know, for population version, we write P. For sample version, we write P of S. Now let's talk about the formulas. P of S is X by N. Okay, I'm telling you, this is X by N. This is how you define X by N. Just like you define the sample mean as summation X by N, here you define it as X by N. And here this X is basically number of successes. For example, if the question says an experiment is performed 100 times, the number of successful outcomes is 46. Number of successful outcomes is 46, implies X would be 46. Okay. So by now you know that your sample proportion is PS, which is written as X by N. So you are good with this part. Okay. Now we are basically trying to discover things. So you know that X, that is basically the number of successes, is binomially distributed. Okay, don't like, if you're not able to understand it, that is completely okay. When we will discuss the example, you will understand it. Okay, just know that since X is binomially distributed, E of X is NP and variance of X is this. This is what you have told me. Okay, this is what you know already. Okay, so you have these
Yes.
two things. You know this. Perfect. We need to find the expected value of P of X. Okay. I'll try to give you a quick reference. Uh, okay, so this basically is expected value. I am not using the eraser because for some reason, whenever I use eraser, I am not able to write properly. Of sample mean is equal to mu, right? You know this, right?
Yes.
So this was for sample. This is for population. You will see a similar relationship here. This is for sample. This is sample proportion, and this P is population proportion. And by derivation, we got these equal, right? So we have E P of S equals P. This is the expected value of sample proportion. That is basically the population proportion. Okay. So, but the thing is that how did we get this? Expected value of PS equals expected value of X by N. How did we get this? PS is X by N. Simply we have just used X by N instead of PS, right? So you know that I can take this N out directly, right? Because I can take out any constant when I'm finding expected value. So I have 1 by N e to the X. So e to the X is NP. We have discussed that. So I am going to get 1 by N into NP. I can cancel out my N's and I will get my P. Okay. So even if you are not able to understand this derivation, just know that we have this relationship. Okay. Are you clear with this part?
Yes.
Okay. Okay. So far, you know that the expected value of of the sample proportion is equal to the population proportion, right? And if you do similar derivation for variance, okay, you are going to get P over 1 minus P over N. Here, these things are extra. If I tell you honestly, these things are extra, but I am going to explain this to you through a relationship. This is why I'm just, writing it down. Okay. And expected value of x bar is mu, and variance of x bar is sigma square by n. Right, Anjali? Yes, do you remember this?
Yes, ma'am.
Okay. And in the previous part, we have discussed how to find the confidence interval for mu. Can you please tell me the formulas? Like we have mu here, less than equal to. Yeah, and how what do I write here? X.
Bar
Very good.
minus
Mm-hmm.
yeah, sigma square by root of n.
Sigma z by under root n.
Yeah, sigma z by under root n, and x bar plus sigma z by under root n.
Very well done. Okay. So we already know this, that this is the confidence interval for mu, that is the population mean. And now we are trying to find the confidence interval for population proportion. So things are same, like it's just that they are two different parameters. Oh, sorry. Yeah, population proportion. Okay. All right. So here the confidence interval would be, first of all, population proportion is written as P. This is going to come in the center. Then I'm going to write PS minus Z under root PS 1 minus PS divided by N, PS plus Z under root PS 1 minus PS divided by N. Okay. All right. So far I've just written the formula. This is PS minus Z under root PS 1 minus PS divided by N. Okay. This is the population proportion. Just like this is the population mean. Okay. This is the sample proportion. Just like this is the sample mean. Are you there, Anjani?
Yes, ma'am.
Okay. So can you see some similarities between both these intervals?
Yes.
Okay. And even if you are not being able to, if you're not able to find them similar, that is completely okay. Just know this formula, okay? Although the underlying logic is same, like you have Z here, you have Z here, you have under root N, this is standard deviation, this is standard deviation, because like this is variance. So under root variance is standard deviation. But if you are not able to understand it that way, just learn this formula, okay? So this is confidence interval. Interval means it would be a range. This is a range. here in the center you have population proportion. Okay, and now how are you going to find PS? Okay, so PS is x by n. I told you the formula. So you have your PS, you have your n, you would be able to find 1 minus PS, and for Z, again things would be similar. Again, you need to find probability. From probability, you need to use your Z score table. Once you have your Z score table, you can easily find Z. Once you have everything, you only have to plug in values and you will get your interval. Okay.
Okay.
So did you understand this?
Yes.
Sure.
Yes.
So have you like noted down the formulas?
Yes, I have.
Okay, even if you have not, I will share them with you. But please, when you are learning, make sure you're learning it correctly, because like at times students just like I've noticed that you say sigma square again and again, but this is sigma. Okay, so like
Sigma.
if you will say the sigma square again and again, you will learn it this way, and then obviously you will do it wrong in exam. Okay, so statistics is all about formulas, and yes, you should know some underlying logic as well. Like here I tried explaining you the new section with reference to the old section, and you were able to understand it much more easily, right? So I'll delete this and I will just quickly summarize. We'll do the examples in next class. We have mean as parameter, we have variance as parameter, and we have proportion as parameter, right? Then the second question comes sample and population. Sample mean is, can you please help me with filling in this table? Sample mean is x bar, sample variance is
Sample variance is S.
s square. Okay, variance is
S
square.
square.
Okay, yes. Sample proportion is p s. Population mean is this. Population variance is sigma square.
Square.
Population proportion is simple p. Okay, I will not write down the formulas to confuse you, and to just uh, yeah. Okay, okay, so all right, and the two intervals are, like we have discussed, two intervals: confidence interval for mu and confidence interval for p. Okay, so it's quite self-explanatory. We'll have mu here, we'll have p here, less than equal to, less than equal to x bar minus sigma z by under root n, x bar plus sigma z by under root n, less than equal to, less than equal to ps minus, we are going to have z ps 1 minus ps divided by n, and we are going to have ps plus z ps 1 minus ps divided by under root n. Okay, so just know these formulas, and ps is basically x by n. Obviously you will get a better idea of this part in the next class when I will discuss the examples, but so far are you clear with this much?
Yes.
Are you sure?
Yes.
Okay, I'll stop the recording and then we can discuss.